Hi everyone, I am Rica Antonio from BS Fast 2A and I'm going to discuss to you the red algae or the red seaweed. Afterwards, I'm going to discuss some of the species of the red algae. Let us now discuss the red seaweed, red algae, also known as Rhodophyta. Rhodophyta are one of the oldest groups of eukaryotic algae. The Rhodophyta also comprises one of the largest phyla of algae, containing over 7,000 currently recognized species with taxonomic revisions ongoing. Here are the general characteristics of red algae. They are lack of flagella and centrals, but they have the presence of photosynthetic pigments, found both in marine and fresh water. They show biphasic or triphasic life cycle patterns. They are multicellular filament blade structure. Stored food is in the form of starch and polymers of galactan sulfate. Now let us discuss some of the species of the red seaweed. First is the Gracilaria verrucosa. Let us now discuss what is Gracilaria. The genus Gracilaria was established by Greville in 1830 and is the third largest genus in the red algal group, with over 150 species worldwide. Nearly 28 species of Gracilaria have been reported from the Indian coast. Gracilaria is mainly cultivated and harvested for agar production, currently providing more than 50% of the world's supply of agar. In addition, Gracilaria is also being used as food in soups and salads in several countries such as China, Japan, Korea, Thailand, and the United States. Ecology of the Gracilaria verrucosa, essential for management and conservation of seaweeds, providing information on where each species can be found, where they grow most luxuriantly, and their habitat preferences with respect to seawater depth, light intensity, substratum type, wave action, water turbulence, and salinity. So seaweeds serve important ecological roles, such as primary production and the storage and cycling of nutrients. They also provide habitats that support enhanced secondary production. Let us now proceed to the biology of the Gracilaria verrucosa. The top of the seaweed has many branches and feels soft to the touch compared to the coarse, dark bottom of the plant. Red ceramium is branch resembling Polysyphonia, but has spincer-like structures at the end of each of the branches. The genus of Gracilaria is cosmopolitan in distribution and has been reported from the Arctic, temperate, and tropical region. Greville set up the genus Gracilaria in 1830, which comprised then only 4 species. Gracilaria is common in quiet, shallow water and is most abundant in the warm summer month. It is commonly found floating over muddy or sandy bay bottoms. Sporophytes and gametophytes of Gracilaria occur alternately in its life cycle. Mature tetrasporophytes produce tetraspores, some of which develop to male gametophytes, while other grows to female gametophytes. The male mature gametophyte forms spermatangia. The female forms carpongonia. Let us now proceed to the Asparagopsis armata. Asparagopsis armata is a species of marine red algae. They are multicellular eukaryotic organisms. This species was first described in 1855 by Harvey, an Irish botanist who found the algae on the western Australian coast. Marine algae like Asparagopsis armata are considered autogenic ecosystem engineers, as they are at the very bottom of the food chain and control resource availability to the other organisms in the ecosystem. Asparagopsis armata have a triphasic diplohaplontic heteromorphic life cycle. In this life cycle, the three phases include haploid, gametophyte, and diploid zygote. Multiple phases of different morphology and ploidy contribute differently to the expansion potential of Asparagopsis armata. Gametophytes of this species are microscopic, and which divide into tetrasporophytes that go through meiosis to be developed into the gametophyte. Asparagopsis armata has two morphologically different stages of the development, the gametophyte stage and the tetrasporophyte stage. Asparagopsis armata goes through haploid and gametophytic phases in a heteromorphic diplohaplontic life cycle. The Asparagopsis armata gametophyte grows into adult to form and goes through fecundation to produce diploid, which then divide into tetrasporophyte that goes through meiosis to be developed into the gametophyte.